So if we take the sum of the x values, it's going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's going to be 21. Let me put this in a different color. Now let's take the sum of the y values. 2 plus 4 plus 7 plus 9 plus 12 plus 14. So that gives us a sum of 48. Now, we need to determine the sum of the product of x and y. So 2 plus 8 plus 21 plus 36 plus 60 plus 84. So that's going to give us 211. Now the sum of the x squared values, 1 plus 4 plus 9 plus 16 plus 25 plus 36. So that's going to be 91. And then the sum of the y squared values, 4 plus 16, 49, 81, 144, and then plus 196. So that's going to be 490. So this is the sum of the x values. 48 is the sum of the y values. And 211, that's the sum of xy. 91 is the sum of x squared, and 490 is the sum of y squared. So once we have those numbers in red, we can now plug in the information into the formula to get the answer we need. So I'm going to delete everything up to there. And here's the formula that we need. So the correlation coefficient R, which in some equations is represented by the Greek symbol rho, n times the sum of xy minus the sum of x times the sum of y, divided by the square root, and inside the square root it's going to be n times the sum of the x squared values minus the sum of x values, but we're going to square that. So be careful with that difference. And then it's going to be n times the sum of the y squared values minus the sum of the y values, and then squared. So let's plug in everything into that formula. So it's going to be n, well, we need to know what n is. And if you recall, there were 6 x values. 1, 2, 3, 4, 5, 6. So n is the number of values that we have in one single column. So that's 6 in this example. And then times the sum of xy, which is 211, minus the sum of the x values. So that's 21. And then the sum of the y values, that's 48. So at this point, we just gotta plug everything into this formula. And then it's going to be n times the sum of the x squared values, which is 91, minus the sum of the x values squared. So that's 21 squared. Then it's going to be n times the sum of the y squared values, which is 490, and then minus the sum of y, which is 48 but squared. So that's what we have so far in this example. Now let's plug everything in. So we can get rid of these numbers. 6 times 211 is 1266. And 21 times 48, that's 1008. Now, 6 times 91, that is 546. 21 squared is 441. Now 6 times 490 is 2940. And then 48 squared That's 2304. Now let's subtract 1266 by 1008. So that's 258. And then we have 546 minus 441, which is 105. And then 2940 minus 2304, that's 636. So far we have r is equal to 258 divided by the square root. And now let's multiply those two numbers. So 105 times 636, that's 66,780. So if we take 258 and divide it by the square root of 66,780, we get an r value of 0.998. So this r value is very high. This indicates that there is a very strong linear relationship between the x and y variables that we have in this problem.